Everyone, welcome to Graphing Rational Functions. This is Nicholas JMV. So today the goal is to graph a rational function, but we're going to limit this and we're not going to talk about common terms, okay? So this is I guess I would call simple examples or just a little bit easier examples, okay? So let's go ahead and get started. First of all, a rational function is the quotient, or when you divide two polynomial functions, okay? Generally speaking, we don't want q of x to equal 0, and we'll talk about that in a few minutes, okay? But this is the general form, okay? So when you graph these, I always kind of look at these things as the big four here. I call them the big four in class, okay? And these are the four things that most of the time I'm going to look for when I graph a rational function, okay? I'm going to look for the x-intercept, y-intercept, vertical asymptote, and horizontal asymptote, and after that I'll probably plot a table of values. So to find the x-intercept, okay, the x-intercept means that y has to be 0, and the only way to make a fraction 0 is to set your numerator equal to 0. So in this case you set p of x equal to 0. Okay, so your numerator. The numerator goes to 0, okay? Now the y-intercept is a little bit different. You just set x equal to 0. So set x values, all your x values equal to 0. So you're going to essentially just ignore them. Okay? The third one is the vertical asymptote, and when we did reciprocal functions, we talked a lot about these last two. A vertical asymptote happens when your denominator equals 0. Okay? So it's a little bit different than the x-intercept. X-intercept, your numerator is equal to 0. The vertical asymptote, your denominator. Okay, and I abbreviate, the denominator is equal to 0. Okay? Lastly, the horizontal asymptote. Now that is found three ways. Okay? If you have a numerator, your degree of your numerator is smaller. So that means if your degree of your denominator is larger, your horizontal asymptote is 0. Y equals 0. If they have the same power, you're going to divide leading coefficients, and that's what we talk about with y. Okay, and we'll talk about that later. If the degree of the numerator is equal to the is greater than the degree of the denominator, there is none. Okay. We also have this thing called a slant asymptote, but for our class, we're not gonna talk about that. But there is what's called a slant asymptote. Okay. So let's go ahead and look at our first example. So we're going to graph the function f of x equals x plus 2 over negative x plus 3. They also want us to state the domain and the range. So let's get started. I'm going to start just right away just with my x-intercept. My x-intercept is when my y value equals 0. So remember, y equals 0 here. Okay, and that happens when you set the numerator equal to 0. That's the only way to make a fraction equal 0. So x is negative 2. That means it's the ordered pair, negative 2, 0. So that's right here. So I'm going to plot as I go. The second thing I'm going to do is I'm going to go ahead and find my y-intercept. Okay, and that's essentially what you're looking at is just ignoring your x values. You just set x equal to 0. Okay? And this one is going to be a little bit challenging. So if you ignore this, you get 2/3. So y equals 2/3 is our y-intercept. So 0 over and 2/3 up, maybe right about here. Okay, it's about as close as I can get. So I'm halfway to my big four. My third one, let's look at the vertical asymptote. Okay, the vertical asymptote is also where you have these things that we call them discontinuities. Okay, and then we'll talk a little more about that in class, discontinuities. So if I want my vertical asymptote, I set my denominator equal to 0. Okay? And so I get negative x equals negative 3. So x equals 3. So there is going to be a vertical line at positive 3. So at 3, I'm going to go ahead and draw this dotted vertical line. Some people make them solid. I just do dotted, or dashed, I guess, is more accurate. There's my vertical asymptote. Let's go ahead and find my horizontal asymptote. Now, the powers are equal here. They're both first-degree polynomials. So that means I divide the leading coefficients. The leading coefficients here are 1 in the numerator, negative 1 in the denominator. So 1 divided by negative 1 equals negative 1. So I'm going to go ahead and draw my horizontal asymptote. So there we go. Now notice I already have a couple points here. Okay, and so what I can do is I can plug in another value. Okay, and so now I have to make this table of values. So I'm going to give myself some space. Okay, and I make an X and I make a Y. And I want to be smart about my choices. So I have -2, I have one for 0. If I plug in 1, that's going to be a law of, I'm actually going to plug in 2. And why am I plugging in 2? As you'll see, if I look at the numerator, 2 plus 2 is 4, divided by -2 plus 3 is 1. So that's just 4. So I picked 2 because I get a nice Y value. I get 2, 4. So 2 over 4 up. And so I'm going to go ahead and, oops, that is a pretty bad sketch. It's hard to do from a tablet. Let's see if I can do this a little better. So here's our first branch. Okay, so I got to find the other branch. It's going to be down here somewhere. So let's go ahead and plug in 4 here. So I'll plug in 4 because 4 plus 2 is 6 in the numerator. -4 plus 3 is -1, so I get -6. Okay, so 4, -6, so there's 5 maybe right here. Okay, and so if I plug in 6, or I plug in 5, that's going to be tough. So I'm actually just going to go ahead and try to sketch this general function, follow the asymptotes like this. I've got my 1 point there, that's good enough. Okay, so that's how you graph rational functions. I'm going to stop with this video and I'm going to do a second video with some more examples. Okay, but before we end this, let's go ahead and state our domain. The range, if you look at the graph, you might be able to get it. The domain is all real numbers except for, look, I can go all real numbers except 3. So there's a couple ways you can do this. You can go -infinity to 3, and then union with 3 to infinity. That's the domain. The range is all real numbers except for -1. So that's from -infinity to -1, and union with -1 to infinity. So if you have any questions or comments on how to graph these, go ahead and type them below, and we'll see you next time.